Good morning to all. Next we have discussed. So meta class. So a meta class is a class whose instances are themselves the classes, and languages are such as Smalltalk and CLO support to the concept of a meta class directly. C++ does not. So some of the classes will be only to support to the particular meta classes, that is the Smalltalk and CLOs, but not support to the C++. Okay, object oriented is not support to the particular meta classes. See here the temporary data in the different temporary data is there in the different operations will be performed to the particular meta classes. Okay. Next, the interplay of classes and objects, that is the relationship between the classes and objects. Okay, so classes and objects are separate at intimately related to the different type of concepts. So actually these are the separate, but some of the operations will be like some of the processes will be equal. And the classes are static, therefore their existence, semantics and relationships are fixed prior to the execution of a particular program. So in that say, what we say, the classes are the static. Whenever we can assign the properties of the classes and operations and the class name, these are the static. So it will not change the particular execution time. Then in that way we can say that these are the static. And similarly, the class of most object is static, meaning that once an object is created, if its class is fixed. So when the object will be created, automatically the class will be fixed. However, objects are typically created and destroyed at a furious rate during the lifetime of the particular application. So lifetime means based upon the creation, destruction of the particular object. Okay, and specifically every object is the instance of some class. So every object is the instance of some class, but every class has 0 or more instances. Okay, it may be object or not, but object is always instance of a particular class, and the class may be 0 or more instances. Okay, see, the instance of classes are dynamic, that is the objects are the dynamics. The two objects should not occupy the same space at the same time. So in that way we can say that the objects not specify the same space at the same time. Okay, see here we can define the class name as the fruit, and likewise we have to assign the Java or object oriented class colon fruit. There is the name of the fruit. See here different type of fruits are available. There is a banana, apple, pineapple and strawberry. These are the occupied different spaces, not the same space. Okay, even go for the animal, we have to assign the different type of animal. There is a dog and sheep. This is a can write and is yellow is the property, can run one is the property, and go for the sheep. This is one of the properties, the white and run to the faster. So likewise we have to assign different of spaces allocated. Okay, next one. So roles of class and objects in analysis and design, that is during the analysis in the early stages, the developer has two primary tasks. The first one is identify the classes and objects that form of the vocabulary of the particular problem. So first of all we have to identify what are the classes and objects are form in the vocabulary of the particular domain, and invent the structure whereby the set of objects work together to provide the behaviors that satisfy the requirement of the problem. So which object to be satisfy the particular problem. Okay, and collectively we call such a class and object as a key abstractions in the particular domain. Okay, so and we call these cooperative structures at the mechanism of implemently. Actually we can say it is these are the mechanisms for the implement of the particular application. Okay, and during these phases of development, the focus of the developer is on outside view of these key abstractions. So first of all, whenever we can develop a particular system, the developer go for an outside of the view. So identify what is the outside of the view will be assign the particular system, then we can go for the to implement the particular system. So what is the process will be going on outside of the particular problems. So first of all we want to identify, so what is the process in the outside, what is the problems in outside, what are the problems in outside the particular applications. Okay, and this view represent the logical framework of the system and encompasses the classes, structure and object structure of the particular systems. Okay, and the next one, in the later stages of design and the moving into the implementation, the task developer changes, that is the what is the inside of the view of the particular system abstract mechanisms involving the position present. Based upon the physical representation, we can identify what is the problems in the inside of the view, what is the process will be going on inside of the view, what are the abstractions, what is the mechanism that perform the particular inside of the view. Okay. Next, on building the quality of class and objects, we can define the different type of measurings from the quality of abstraction. See, measuring the quality of abstractions, the first one is a system should be built with a minimum set of unchangeable parts. Whenever we have to construct a particular system, some of the parts are the unchangeable things. Okay. And next one, the design of classes and objects is an incremental and iterative process. Okay. And the based upon the design of classes are the most in the incremental and iterative process. Here we can assign the 5 meaningful metrics to know the which class or object is well designed. So these are the different type of 5 meaningfuls. The first one is the coupling, second one is the cohesion, third one is the sufficiency, fourth one is the completeness, and fifth one is the primitiveness. Next, first one, coupling. Coupling is the measure of the strength of association established by a connection from one module to another. This is the simply we can say connection between to the one module to the another module. So whenever we implement a particular application, in that application based upon that different type of modules are available. In that based on different modules, one of the group will be implemented different modules and they are interact and they are can be coupling to all the modules. Okay. And the cohesion, the measure the degree of connectivity among these elements of a single module. The based upon single module you can use it. First one is the least desirable form of cohesion is a coincidental cohesion, and the most desirable form of cohesion is a functional cohesion. So these are the coincidental and co-functional, the based upon the least and most. Okay. And the sufficient mean that the class or module capture enough characteristics of abstraction to permit meaningful and efficient instructions. So we can assign the different type of characteristics based upon the particular module. It will be sufficient or not. Okay, if it will be sufficient, we can go for the interact with the operations. And next one is the complete, that meaning that the interface of the class or module captures all of the meaningful characteristics of the particular abstraction. Okay. Next, primitive, the operations are those that can be efficiently implemented only if given access to the underlying representation of the particular abstraction. So likewise we can implement to the particular operations. Okay. So these are the 5 metrics. The first one is the coupling, second one is the cohesion, third one is the sufficient, fourth one is the completeness, and fifth one is the primitiveness. Okay. So here we can assign the different type of operations in the functional semantics. The following criteria to be considered when designing the methods of a class as a whole. The first one is the reusability, second one is the complexibility, third one is the applicability, fourth one is the implementation knowledge. So first one is usability, that is what would this behavior to be more useful in the more than of one context. So based upon the context, the reusability is the perfect or not. So it will be how to useful. So it will be useful or not. So how much it will be useful to the how much more it will be useful in the particular context. And the complexity is how difficult is implement on the particular behavior. When how to implement the behavior of that is how it is difficult. So first we have to identify that one. And applicability, how relevant is the behavior. So how it will be relevant to the particular behavioral type it will be placed. And implementation of knowledge, the behavior's implementation depend upon the internal details of a type. It will be depend on the internal. Okay. And next one, time and space semantics. We must specify our decisions about the amount of time it takes to complete an operation and the amount of storage it needs. See, message passing, it may take the one of the following forms. Here in the message passing we can assign to the 4 types. The first one is the synchronous, next one bulking, next one timeout, next one asynchronous. So first one is the synchronous, bulking, timeout, and asynchronous. Okay. So what is the synchronous? An operation comes only when the sender has initiated the action and the receiver is ready to accept the message. So whenever the sender will be initiated the particular message, automatically the receiver will be ready to receive the accept the particular message. It is called as the synchronous. So the sender and receiver will wait indefinitely until both parties are ready to proceed. Okay, this is called as a synchronous. And what is the bulking? The same as synchronous, except that the sender will abandon the operation if the receiver is not immediately ready. That is, sender is ready but receiver is not ready. This is called as a bulking. Okay, and timeout, the same as synchronous, except that the sender will only wait for the specified amount time. So here only the so that is the receiver is not from the ready, but the sender will wait for some time. Okay, that is called as a timeout. And asynchronous, a sender may initiate an action regardless of whether the receiver is expecting to receive the particular system, like particular message or not. Just he will initiate but not identify. So he was accepting or not, he was likewise, there is no intimation. That is called as asynchronous. So in the message passing we have to assign the four things. The first one is the synchronous, that means sender and the receiver is at a time they have to receive the messages. And bulking, the sender will be amount and the receiver is not immediately reply. And timeout, sender wait for some time, and asynchronous, sender initiate an action but not wait for the receiver. Okay, these are the message passing that are for different of our following operations, that is the synchronous, bulking, timeout and asynchronous. Next, choosing relationship, that is the collaboration, that is choosing relationship among class and among object is the link to the selection of operations. So based upon the operation, the classes or objects may be linked to one to another. So coupling is a measure of the degree of accessibility. Okay, and the mechanism and visibility, deciding upon the relationship among objects is mainly a matter of designing a mechanisms whereby those objects are interacted. So what are the objects are interacted with the particular mechanisms? Okay, see, for example, there are four fundamental ways that the object X may be made visible to object Y. See, the supplier object is global to the client. So that is a global means everybody will be such that, and the supplier object is parameter to some operation to the client, only some of the parameters of the client. The supplier object is part of the client and supplier locally declared object in the scope of the object diagram. So here we can assign different type of fundamentals. First one is the global, next one is the parameter, next one is the part of the system, next one is the local. Okay, these are the visibility of the mechanisms. Okay, so supplier object is global to the client, the supplier object is a parameter to the some operations of the client, and the supplier object is a part of the client object, and the supplier object is a locally declared object in the scope of the particular object diagram. Okay, and the next one, choosing implementations. See, the representation of class or object should almost always be one of the encapsulated secrets of the abstraction. So this is called as the representation. And packaging, the competing requirements of visibility and information hiding usually guide our design decisions about where to declare the class and object. So the guide or design, our decisions will be defined. So where we have to declare the class and objects. So where the class will be declared, where the object will be created. So everything will be depending on the particular requirement of the visibilities. Okay, and the next one is classification. So classification is the means whereby we order knowledge. That is, what are the classifications are most important to the particular system, that is the implementation of the particular system. See, in object-oriented design, recognizing the sameness among things allow us to expose the commonality within key abstractions and mechanisms, and eventually leads us to smaller and simple architectures. Unfortunately, there is no golden path to classification. There is a arranging of elements into different groups on the basis of the similarities in their properties is called classification elements. That is the elements. That is the, what is the classification element means? That is in the arranging the elements into different groups on the different basis their properties. Okay, and next one, the classification of similar elements into groups makes the study of element is the faster. So which is the faster the elements can identify in the classifications. Okay, and the next one is, see, the importance of proper classification and the classification object oriented development, that is the difficulty of classifications. See, example of classification and incremental. These are the most important examples of classification and incremental of iteration nature of the classification. See here, the classification is a means whereby we order knowledge. So where we have to order the particular knowledge, we can identify the particular systems. Okay, so we can assign. So how we can classify the particular system? How we can have the object has been defined the particular classifications. This is the diagram of the classification in the means whereby we order the knowledge. It is the one of the classification diagram. Okay, next. The classification and object-oriented development. See, the identification of classes and objects is the hardest part of object-oriented analysis and design. It is the most important from the to identify the classes and objects in the object-oriented analysis design. Okay, because of it is very hardest part. Because of why you can say it is the hardest part means, so which classes we have to identify, which objects will be defined, what are the process will be going on, everything will depend upon the identification of classes and objects. So in that way we can say that in the classification of object-oriented development, the identification of class and object is the most hardest part of the analysis and design. Next, identification involves both discovery and invention. See, through discovery we come to recognize the key abstractions and mechanisms that form the vocabulary of our problem domain. So it will be depend upon our problem domain. Through invention we devise generalized abstractions as well as new mechanisms that specify how objects collaborate. So which are objects are we collaborate to the particular generalized of abstractions, when we have to create new mechanisms that specify how the object will be created and how the object has to be collaborated. Okay, ultimately discovery and invention are both problems of the classification. So these are the two problems from the classification, that is the discovering and inventions are both problems. Oh, and a classification is fundamentally a problem of finding sameness. So it is one of the problem of the same of the fundamentals. Okay, when we classify, we seek to group things that have the common structure or exhibit a common behavior. So first we have to classify which are the group of the common structure available, which are the common behavior. So we have different of modules. So in the different modules, which are the common things available, which are the behavior, which are the module has the same behavior, which are the structure is the same. For that we have to identify. See, in that way we can say that when we classify, we seek to group things. That is, we have to seek what are the things that have the common structure and exhibit of the common behaviors. Okay. And the next is the classification help us to identify generalization, specialization, and aggregation hierarchies among the classes. And we say that here the classification help us. So which relations do we have to assign the different of classes? It may be generalization, or it may be specialization, or it may be aggregation. So in that, so which relation we have to define in that way classification we have to easily identify. So generalization, specialization, and aggregation relation into the hierarchy among of the classes. Okay, so these are the most important relationships from the classes. That is the generalization, specialization, and aggregation from the classes. So which relation be between to the different of classes? So we can implement it may be generalization, or it may be specialization, or it may be aggregation. Okay. Next. Next one is classification. That is, a classification also guides us in making decision about a modularization. So whenever you go for the modularization, it will be guides, the classification will guides how the decisions will be made into particular modularizations. Okay. And next one is we may choose to place certain class of objects together in the same module. So how we can choose the particular classes and objects will be in the same module or in different modules. So what are the classes will be set to place on the certain classes, and what are the objects will be assigned in the particular module. It may be same module or different modules. See, we may choose to place certain classes and objects together in the same module or in different modules depending upon the sameness we find among these declarations. So based upon this declaration, we can assign what are the classes will be assigned to the module, what are the different of classes are assigned to the different of modules. And classification also plays as a role in allocating process to the processor. So different type of roles will be defined to the classification. See, we place certain processors together in the same processor or different processors depending upon the packaging or performance reliability concerns. So in that, the classification is placed in the different type of processors that may be so how we can assign the particular processor or different processors depending upon the, it may be packaging or performance, or based upon, that is the based upon the packaging or based upon the performance or based on the reliability concerns, we can place to the particular processor, different processor depending upon the packaging and performance and reliability concerns. Okay, this is the classification. So what is the classification guides? So what are the classes and what are the objects which may be placed to the different modules or different the same modules, and depending on the sameness we can find the declarations, and it will be play a role the different of a process based upon the packaging performance and reliability concerns. Okay.